All right. Right. So we move on now. We went through all of these already from the last class. Note area is for a 2D shape, right? And volume is for a what? It is volume for 2D or 3D shape.
3D, sir.
3D
3D
shape.
shape.
Yeah. So um, and our unit. What is the unit for area?
Square, sir.
Meter squared. And what is the unit for volume?
Cube.
Meter cube. All right, beautiful. So we
Cube.
can continue. Um, you will get these notes by the end of the day, right? Hopefully, you will have an activity. This class won't be long. This class will last for hopefully about 20, about 20 or so minutes, 20 to 30 minutes. Hopefully, this class will last that long, and then you will get an activity afterwards. So we looked on the volume, and we essentially spoke about volume yesterday. That is the amount of space that an object takes up in a three-dimensional area, or the size of a 3D shape, right? So these represent the shape of the shape and sizes of these um different different objects. Now, I stated yesterday that if you're going to calculate any of these, right, more than likely you're going to calculate a cube, a rectangle, a prism, a sphere, and a right circular cylinder, right, and maybe a right circular cone. But if you're going to calculate any of these, I will give you the formula, right? This is not mathematics. You don't need to actually memorize the formula. I will give you the formula, and you can go ahead and calculate it. All right. All right. So the volume of a regular shaped object. So this is just an example of the volume of a irregular shaped object, right? So we have a sphere, and there's a problem. There's a little problem. Let me just go ahead and fix it quickly. Give me 1 second. Keep on this person. There's a slight issue here. Slight issue. Give me 1 second, guys. All right. All right. So we can continue. All right. So we have our shape here, right? It has a diameter, right, of 2.6 meters, right? So what would the diameter be? What would the diameter represent? Somebody want to give it a try? What's the diameter? All right, Rutan, I see you raise your hand.
1.3.
The diameter, no, it says that the diameter here is 2.6, right?
Yes, sir.
Yeah, so what exactly does the diameter represent on this, say, diagram here?
One.
Come on, let us just look at the diagram for a second, all right? The diameter represents the distance from here to where?
The other side.
Sir.
Over the other side, right?
Yes, sir.
So this would be 2.6, right? 2.6. So
Yes, sir.
Yes.
the formula says that the volume of a sphere is 4 over 3 times pi times r. What is r?
Radius.
Right. So
Radio.
r is our radius.
R.
So what is our value for r? Or how do we calculate r? Hmm? How do we go about
Radius,
calculating
sir.
r? Yeah, it's our radius, but what is the value? How do we calculate the value for r?
You multiply something.
No. What is our r on this diagram here? If this is our radius, where does our r? Where's our r? Is this
From that to me go, sir.
from here to the middle, right? So it will be half,
Yes, sir.
right? It will be
Yes,
Divide it,
half.
sir. Half of that again.
I hear a
divide it by
question? Right. So the
by
diameter, we divided that by 2 so to get our radius, right?
Yes,
Yes,
sir.
sir.
So let's do that. So r is equal to diameter divided by 2. Our diameter in this case is what exactly? The value
6.
2.6.
2.6.
2.6. So we divide that by 2 and we get
1.3.
1.3. Dumplings, yams, bananas, what? 1.3 what? Right.
Meter.
1.3 meters. All right. So we have everything that we need. For the formula, we have our R, right? So now we will go ahead and calculate the R. So it of course it's already done here, but let's just do it together, right? Um, so V equals 4 over 3 pi R cubed, and then this would be equal to 4 over 3 times pi times 1.3 cube. We just plug in the R in this formula here. Now, what is the value for this? 1.3 cube. Could somebody calculate that? What is the value for 1.3 cube?
3.
I hear somebody with the answer.
3.9.
Right. 1.3. No, that's not what I'm getting. Try again. So that would 1.3 cube would be 1.3 times 1.3 times 1.3, right? So what is the value for this?
Sir, 16.87.
Go again? Mm-mm.
16.387.
No.
2.197.
Yeah. So that would be 2.197. Remember, the
So, sir,
cube,
oh, you do that now.
right? The cube is representing that we have 1.3 being multiplied by itself 3 times, right? So if this was 1.32, 1.3 squared, what would we have? 1.3 times what?
1.2.
Times what? If we have 1.3 squared here, we'd have 1.3 times what?
1.3, sir.
Yeah, 1.3. And if we had 1.34 to the fourth power, we'd have what? 1.3 times,
1.3 times 1.3 times
right?
1.3.
So it depends on the value of the exponent, right? Exponent being a 4 right here.
Yes, sir.
So let me just rub that out for, right? Just an example. So yeah, now our value for 1.3 cube is 2.19, right? 2.19. So we have that here, 2.197, I think, 2.197.
Yes,
So we plug that in now into our equation. So we have 4/3 times pi times 2.197. All right. Now, could somebody work this out for me? Is that possible?
yes, sir.
Yeah. So let's try it. Let's try work this out. So 2.17 times pi is how much? 2.17 times pi. 2.17 times pi. What are we getting? Uh, Repeat that for me, please. 2.17 times pi. What are we getting?
10.85. Something like that.
10.8? No. All right, type
10
in
point.
your calculator. All right, I see a message in the chat. All right, good morning, Ronaldinho. All right, to type it in the calculator. Right, we're coming over here. Type this into your calculator. 2.19 times 3.14. Remember that pi is approximately 3.14, right? So type this in and see what you get into your calculator.
Sir, 6.89858.
Right, 6.89, right? And then we'll times this by 4. You see the 4 down here? The 4 is in the same line, right? Same line. So we times that by 4. And what do we get now? Times that by 4. 6.89 times 4.
27.59432.
Right. And now, all right, so we get, give me a second. So we get 27 point what?
59432.
59432. All right. We can put that to 2 decimal places. So that would be just 27.59, right? Over
Yes,
3, right? So what is our
yes.
final answer? Fix this properly.
9.
I hear it. 9 point.
9.56666667.
All right, so let's do it again. 9 point.
19.
19. All right, we can stop there. 19. Right? And what is our I hear a message in the chat. A message. Okay. No problem. No problem. No problem. Remember that the link will be posted on Google Classroom. All right. What is our unit for volume again?
Cube, sir.
Cube, meter cube. Right? The topic for today is area and volume. The big topic up here, right? That's the topic for today, area and volume, and then we'll focus now on volume of a regular shaped object. That's where we're at now. All right. Any questions before we move on?
No, sir.
All right, good. No questions. Anybody else? You can send a message in the chat. Say yes, sir. I don't understand. All right. No. All right. Then I take that everyone understands. We can now move on. All right. This is where it gets interesting, right? Because we spoke about the area of an irregular shaped object, right? Remember we spoke about that. This guy right here, right? The area of an irregular shaped object. We weren't able to find a formula for this. So we had to break it down into pieces, into shapes that we could recognize. Anybody remember this? Right? You remember this, right? This guy right here. So we have to break this down into shapes that we are able to identify. So for figure 1, we broke that down into a triangle. Figure 2, we broke that down into a rectangle. And for figure 3, we broke that down into a square. Now, for the volume of an irregular shaped object, this is where it gets interesting, right? Because we are not able to calculate of the volume for a stone, right? Say we have a stone here. This is our stone, right? We go to the river and we find a stone. We're not able to calculate this. No, we're not able to calculate this, right? There's no formula out there to calculate it. So we have another method. We have another method that we use to calculate the volume of an irregular shaped object, and that's what we're going to discuss now. So to calculate the volume of an irregular shaped object, you will need a container that has a familiar 3D shape, right? So we usually use a measuring cylinder with some water, right, and employ the displacement method. We'll talk about this now. So the volume of water in milliliters displaced is equal to the volume of the irregular solid, right? So the volume of water in milliliters displaced is equal to the volume of the irregular solid. Let me say that one more time. SMS in the chat. All right, no problem. I will remember that these links will be posted. All right, so if after the class you can look over them. All right, so the volume of water, in milliliters that is displaced is equal to the volume of the irregular solid. Now we look at that now, and what does this mean? Right. So we have our measuring cylinder, and our measuring cylinder is at we currently have, what is this value here? What's the value in our measuring cylinder?
60 milliliters, sir.
So 60, right? Good. I love that you're using the milliliters. So we currently have 60 milliliters, right? Now we want to find the area, the volume of a stone, of this particular stone here. I see another message in the chat. Let's check it quickly. All right.
Sir,
Question.
you just go through so many even understand nothing.
I asked you before. If you're understanding. What exactly are you not understanding?
Sir, you didn't even say. You just skip. Sir, you go too fast.
What exactly are you not understanding? Are you not understanding this that we're doing now? I'm not getting a response. Please respond.
Sir,
Could help.
sir, you're not giving us time to write it down. You
Right,
just
that's the problem. I specifically told you yesterday that these notes will be provided on Google Classroom. Were you at classes today?
no.
All right. Well, now we're at class. These everything will be provided on Google Classroom. You don't need to write any notes. So all these the red writings you will see here, these will be up on Google Classroom. So you don't need to
Sir,
wait.
so what if you want writing?
You can go ahead. I'm not stopping you, but you'll be wasting your time and wasting your attention. I want your attention to get what I'm trying to say. Right? We'll be wasting time. We don't have a lot of time, right? For the rest of this class. I want to I planned this remember we just did 2 slides or a couple slides, right? So don't waste your time writing. Don't waste your time writing. I will post these on Google Classroom and then you can write it off if you want. You can go ahead and write it off if you wish. Right? Just pay attention. Please just give me your attention. All right?
Time is money.
Are we good? So what do you want me to
Yes.
go over? For the student, I didn't get your name. The person who had a question, who said that they weren't understanding. What you want me to go over? You want me to go over the volume? This you got this? You understood
Sir,
this?
do what you're doing, and I will go and look over it, sir.
You understood this? Carter,
Yes,
Yes,
sir.
sir. Yes,
Miss
sir.
Carter, please. Thank you. Take that off the screen. You're distracting everyone else. Tonian, please take that off the screen. Right. All right. So we have the volume of an irregular shape object. So as I was trying to say, we have these objects here, right? These are regular shaped objects. We know these objects, so we're able to identify them. Where if we see the box over here, well, this is a horribly drawn box, right? I don't know, but if we look at this, if we can find the area using this formula, so we have a formula for these, and we just took um one specific shape and we found the volume, right? So we had this shape here with a diameter of 2.6 and we were able to find the volume of that. Now, what if we had a stone? What if we had the stone here? Stone. What if we had the stone here? We are not able to find the volume for this. There's no formula here to say that, okay, this is the formula for the stone, right? So we have to use another method to calculate that, right? And that's what we're doing now. We're using the displacement method. And I was in the process of explaining the displacement method, right? We'll come back to this. We'll come back to this slide, but just pay attention for this particular 2 seconds, right? Now, I just want to ensure that we're all on the same page. What is the value here? What is the volume of water in this particular measuring cylinder? What is it saying?
60 millimeters.
Right, 60 milliliters. Right, so we have 60
60
milliliters here.
milliliter.
All right, so we have our stone, and we want to know the volume for the stone. We want to know the volume for the stone. We don't know the volume, right? I'm sorry for my horrible writing. Let me just erase that quickly. Just erase that quickly. All right, so we have our stone here. This is our stone, and we place our stone in the water. Now, what happens when we place our stone in the water?
The water rises, sir.
The water rises, right? Are we all seeing that? Please, please indicate if you're not seeing that the water is rising.
I'm seeing it, sir.
Okay, thank you so much. Right?
You see, sir.
So what is our volume now? What is our volume of water now?
80 milliliters, sir.
80
Right.
milliliters.
So it was at 60, and now it is at 80 milliliters.
It rose 20 milliliters.
So it rose 20 milliliters. I'm so glad that I'm hearing this, right? So this is 20 milliliters. So somebody want to guess the volume of our stone?
20 milliliters.
Very easy, right?
Yes, sir.
20 milliliters. But you can't say 20 milliliters because milliliters is used to measure liquids. So we have to change that now to centimeters squared, centimeter cube, right? Remember we was in centimeter cube, meter cube, thereabout. So 1 centimeter cube is equal to 1 milliliters of liquid. Remember, liquid is measured in milliliters. So we can't say that the volume of the stone is milliliters, right? I would
Yes.
mark you wrong. I would give a 0 or a negative. I would give it a negative mark, right? Liquid is measured in milliliters, but we say that 1 centimeter cube is approximately equal to 1 milliliter, right? Are we all on the same page?
Yes, sir.
We're good.
Yes,
Yes,
sir.
sir.
And we just did that example. Any questions? I hear a question coming.
Sir, size 1 measure 20 centimeter.
20, yeah. So the stone will measure 20 centimeter cube would be the volume of the stone. So volume of stone is 20
20
centimeter cube.
milliliters.
20
Cube.
centimeter cube. Remember that 1 centimeter cube is equal to 1 milliliters. Right? Any questions?
No, sir.
Nope.
Give me 1 second. If you have
Yes,
any
sir.
questions, I can related to air and volume. I don't want any question other than what's relating to air and volume.
No, sir.
Alright, give me a second then. All right. So all right. No problem. So we said that our volume of stone, we have less than a minute. Well, less than 3 minutes. Volume of stone is 20 centimeters cube. All right. So remember that our when we're measuring when our units for volume is either in a meter cube or centimeter cube for now. All right. We in this case the stone is very small, right? The stone is very small, so we don't really want to say we don't want to convert this to milliliters to meter cube. It will be we are very small number, right? Um, but we can just leave it here. Just remember that it is meter cube or centimeter cube for our volume, right? Are we good?
Yeah.
Are we good? We can run through the conversion. You know how to convert from centimeter cube to meter cube?
Yes, sir.
No, sir.
Yes, sir.
We know how to do that? You want to try it?
Yes, sir.
All right. So
Yes, sir.
100 centimeters
1
Sir,
meter.
yes, it was answer. I said it was like a shit.
All right. So meter cube
Whoosh.
with cube this, right? And
Yes, sir.
we would also cube this. This is a kind of difficult. That's why. All right, let's leave it here for now. let's let's leave this here for now. All right, we're
Yes,
going to do this.
sir.
Yeah, let's leave it here for now. This was a lot today. We covered a lot today. Um, just for now, put your volume in centimeter cube or meter cube. All right. All right. So
All right.
now I will send the activity for today have been posted on Google Classroom. Right, the activity for today has been posted on Google Classroom. So go over to Google Classroom. And one more thing before the shuts off, ensure that you put your name in the group. If you have not done so already, ensure that you put your name in the group for your registration.